DARPA shatters optical power beaming record with latest high-energy laser demonstrations. The DARPA led a research team in collaboration with scientists from the U.S. Naval Research Laboratory, and it has set a new optical power beaming record by sending 800 watts of power over 5.3 miles in just 30 seconds, y'all. That's crazy. That's a lot. It's a lot of power over a long time for just 30 seconds, shattering the previous power and demonstration records of 230 watts and 1.7 miles. Interesting. It is beyond a doubt that we absolutely obliterated all previous reported optical power beaming demonstrations for power and distance. DARPA says power beaming will deliver energy to the edge. Interesting. America's military leaders believe power beaming could eliminate the cost and complexities of transporting fuel and power generation equipment to remote locations by generating power in one location and sending that power to another or a more distant location. Power beaming could eliminate the costs and complexities. Energy is fundamental, requiring for military operations, of course, and traditional means of getting energy to the edge, battlefields, disaster zones, the edge of the universe, our solar system, are often incredibly slow, risky, and resource intensive. I mean, how else are we going to power spaceships when they're halfway across our solar system? We got to figure this out at some point. DARPA has previously explored beaming power directly to aircraft and drones while in flight, and beaming power directly into war zones. Several other projects have explored beaming power from Earth to power satellites in space, beaming power collected by satellites down to Earth, and even sending power between spacecraft. That would be interesting. I mean, it's just kind of what we do now, just on a different instance with the bigger planes fueling the fighter jets out while they're out there. It's just the same concept. Just we're gonna figure out how to do it out there. So, let's see. However, power beaming technology still suffers from power and distance limitations, reducing its practical applications for now, as everything for now. The recent power receive array demo PRAD experiments, which took place at High Energy Laser Systems Test Facility at the U.S. Army White Sands Missile Range, increased those thresholds while also demonstrating a viable level of energy transfer efficiency. It's interesting. Customer receiver and high energy optical laser shatter previous records. Kind of what we really went over. Let's see if there's anything else that's pretty good. It says the primary and objective of the test was to although DARPA says the primary objective of the test was to rapidly validate the capability of the new design to massively extend potential distance and not the efficiency. Their system was revealed relatively efficient. According to the test data, about 20% of the transmitted energy was converted back into electricity. So there's 80% loss in the process of it seems. Well, that's fine. 20% now. Next year it'll be 30%. We'll be able to get 30%. The year after that, we'll get 50. And then the year after that, be 80. Year after that, we'll fully know how to completely send and beam this stuff. Guarantee it. It'll only take a couple of years of work. The team collaborated the moment by using some of the transmitted energy to pop popcorn in homage to the 1980s movie Real Genius. So what they do with that power that they sent? What we do as humans? Out of all the things we could do, what did we do? we popped popcorn. And that's how you know that the a bunch of the natives always praise the corn gods. Corn corn's number one. I'll tell you that much. Ain't not much better than corn. God, that's funny. What do we do with that power? We pop some popcorn. That's funny. Notably, the team testified the system with the transmitting lasers and in the new receiver position on the ground. The researchers say that this makes the results even more impressive, since the atmosphere is thickest at ground level. It is a lot easier to send power beams directly up or down relatively to the ground because there is so much less atmosphere to fight through. For Prad, we wanted to test under maximum impact of atmosphere effects. Interesting. Power increase and efficiency improvements. Key goals of Power Phase 2. Here we go. Prad program leaders emphasize that the short turnaround time of the experiments resulted in trade-offs in efficiency. For example, the customized receiver built by the technology company with support of Packet Digital and the Rochester Institute of Technology was completed in just 3 months. For their next effort, dubbed Power Phase 2, the team is looking to test several potential improvements to their existing design that could further increase the distance power efficiency. Yeah, that's what I was saying, of optical power beaming thresholds. Yep, we'll just do it better. They will also explore systems scalability to higher power levels. Yep, and its adaptability to different platforms. Yep, just scale it outwards, such as UAVs. Yeah, that would be interesting. Because then you essentially could, after building like a border wall, you essentially could have UAVs that are constantly in the air, non-stop, just flying around. Because you just constantly be beaming power to them. Not only that, you could do the same thing with water objects, probably too. This is interesting. I like this. This is cool. With the Pratt testing successful, the power program has significantly reduces risk for a key element of making long distance power beaming a future reality. Yeah, I see the potential in it. I mean, of course, who doesn't? This could change a lot of things. This reminds me of a lot of Tesla's ideas, though. Be honest. But what do I know? The program is now moving forward to demonstrate the benefits of integrated relays and vertical power transmissions, and is seeking the creative and innovation of potential partners to accomplish this part of Power Phase 2. And then yesterday was the last day to register for the Power Phase 2 Industrial Day, which will be held on May 29th, so here in a few days. According to DARPA, the event will promote teaming arrangements between researchers, provide potential performers with information on whether and how they might respond to government R&D solicitations, and increase efficiency in preparation and evaluation. Interesting. But let me know what y'all think. Bye bye. See you later. Peace.